Hello everyone. So today we will be discussing about one of the important chapters in the electricity and magnetism section in physics, which is alternating currents. So we will be going in accordance with the NCERT textbook, article wise. We will discuss in depth. Okay, we will be discussing in depth. So the lectures can be quite long, but the purpose is to get a better understanding. And while that is being done, derivations will be according with the we will derive the things properly which will be relevant to your board exams and important numericals we will be discussing. So understanding is important, that's why I will be going in depth. So that once you understand, you don't need to go back to the theory again. You can practice numericals more, spend more time on the numericals. Okay, so today's lecture will be about introduction. We will be getting introduced to what actually is alternating current. Although you might have worked in DC currents, in DC, that is direct current, you might have already understand, or you might have already learned about DC currents, DC voltages and currents. You might have learned. So we will be going with the NCERT textbook. So this is your textbook, and the introduction part we are going to discuss today. Okay, and we will just give a general outline of the important terms used in specifically for AC, such as RMS voltage currents and average currents and voltages, specifically which are used only when we talk about alternating current. So let's get started and let's begin the class. First of all, we need to understand, we will try to learn, we will learn what is AC. Okay, what is AC? We will aim of this section is we will try to learn what is AC. So till now you might have discussed circuits like this. This is a cell connected to this 2 ohm resistor. Say this is 2 volt, current flowing is I amperes. If you'll apply KVL, that is Kirchhoff's voltage law, and Ohm's law in this circuit, so I you will get as V by R, which is equal to 2 by 2 or equal to 1 ampere. This is the current equal to 1 ampere, and it is constant as the voltage applied is also constant. This is a DC voltage. Okay, this is DC voltage. It doesn't change with respect to time. The waveform, if you see, will be like this. If this is time, this is voltage. The source, the cell is producing this voltage. It is constant. It is not changing for time. As time progresses, the value is not changing. Correspondingly, the current is the effect of this voltage, and that is why this current is also constant in nature. These both are DC. This is DC current, and yes, this also we call as DC voltage. Although the full form of DC is DC current, but we call this a DC voltage. This is well explained in your text too, that the phrases AC voltage, AC current, or DC voltage, DC current are contradictory redundant. So alternating current, voltage, alternating current, current. This sounds awkward, but yes, this abbreviation of DC current, DC voltage, AC current, AC voltage is so widely universally accepted. So we follow these. Okay, but whatever, we can say this is a DC voltage, DC current. These are the waveform for DC. Fine, this is when we call it as DC. Suppose another waveform is here. Let us see this waveform. This is IT, okay, time. And if I observe a current like this, in some other circuit, okay, this was about DC, this was a DC circuit. Suppose this is a separate, okay. If we taking suppose some current is IT is like this, flowing like this. So what you can observe from this graph is at different values of time, the value of current is different, and it is randomly changing. Okay, there is no pattern, there is no periodicity, or periodicity in the sense, I mean, it is not repeating after some certain interval of time. It is not repeating, it is just randomly varying. So these kind of currents or voltages, it can be voltage also, are known as variable sources. Since this is current, I will call this as variable current. Okay, if it was voltage, we call it variable voltage, or collectively, when you club them together, you can say variable sources. Okay, this was another. Now, we are in the topic what is AC. So, this was a graphical representation of what different forms that look like. Let us take another example here. Okay, let us take another example. Let's take this waveform. You might have already seen this waveform in simple harmonic motions and where oscillations are there, say motion of a pendulum like that. This is a similar waveform. Okay, current can be like this also. If this is the case, you need to draw some inference from this graph. Suppose we say this is a peak value, this is the maximum value, this value is plus Im in this graph, this is minus Im. This is a sine wave. You can call this as sine wave. This is a sine wave, or we also call this as sinusoidal wave. Okay, this is a sinusoidal wave. Okay, so observe this waveform. In this waveform, if you compare the motion of a pendulum, suppose this is a pendulum, okay, and if we are neglecting air friction so that damping is not involved, if I bring this bob to here, okay, some maximum position, and then leave it, as it has potential energy, it will oscillate. Say this is another negative peak, it will oscillate to and fro about this zero position. This is zero reference. So if it is zero reference, I'm considering here, then it reaches a maximum, then it goes to again zero, that is it will be back to zero, negative, maximum negative equal to that of the positive value it reached here. Then again after begins, again it comes back to zero. Then again the same pattern is observed. After this, when oscillation is complete, another oscillation begins. So this waveform, unlike this waveform, in this waveform there was no such time period that we can say after this waveform is repeating. No, it was not there. So we can't call it as AC. But here, observe the conditions. First, another thing is that in this the current is also reversing its direction. Say from 0 to here, it is positive. After this point, it becomes negative. Then it becomes positive, then negative, then positive, then negative, and so on. But in this case, the current, it's not moving in the opposite direction. It is just in the positive direction. Although the magnitude is changing, but it is not changing its direction. Since two conditions are satisfied here in this graph, you can see current direction is changing, or direction we also call as polarity. Okay, polarity of current is changing here. In this graph, you can see this first condition, polarity of current is changing here. Second, it is periodic. How will you find periodic? That it has, you can find some cycle here. See, one cycle, this is one oscillation like this, or a motion of a swing in an amusement park. You can compare with that. So it is repeating after a certain period of time. This is time period. You know that T, this is one cycle. This is also time period for one cycle. Okay, capital T you call. So these two conditions are satisfied here. See, polarity is also changing, plus minus, plus minus, plus minus, reversing, and periodic, it is also periodic. That is the meaning of word alternating. What is the meaning of alternating? If you search something which begins at a certain position, then it goes to another position, then it comes back again to the initial position, and this process repeats. This is known as alternating behavior. And since you can observe in this waveform, it is following those conditions. So these two conditions are satisfied. Therefore, you can say that this is actually alternating current. This is alternating current. Some different kind of waveforms can also be seen. Okay, you can see that this is alternating current. Fine, you understand the difference? What is the difference between these graphs? First of all, this is constant, so DC. It doesn't vary with time. Absolutely, this is pinpoint constant. This is DC, direct current sources. This is variable source and this is alternating. Okay. Now we will take another example. You can, if I tell you about this waveform, okay, you can just note those waveforms. If I take another waveform, this waveform is like this. What will you say about these kind of waveforms? This is continuing, okay? Infinity. This is a current. It can be voltage also, okay? And this kind of wave, okay, continuing. Time period, suppose say this is voltage, etc. These are all what? These are they becoming negative? Is the polarity of these values changing? Are they going negative? No. So one of the condition is not met. First, second, they are periodic, but it doesn't matter. Even though they are periodic, but the polarity isn't changing, so we can't call them as AC. Also, these are unlike DC. DC is constant. So these are kind of another. We can put these kind of waveforms into another category known as pulsating DC. What are these waveforms? These are pulsating DCs. These are terminologies, and these terminologies are not that just that important to so that you can identify which of the waveforms should be AC. These can't be AC. Okay. If I take another example like this. Suppose if I'm taking example like this, suppose this is a wave. What will you say about this kind of a waveform? This is going to infinity, okay? Suppose this is a current. Suppose this is a plus Im, this is minus Im. What will you say? Is the polarity of this waveform changing? Yes, it becomes positive, then it becomes negative, plus, minus, okay, to and fro. And also there is a period. After this, there is a certain interval of time after which this waveform is repeating. So this is both. This is a periodic waveform as well as polarity is also changing. So this is alternating waveform, alternating current. Okay, this is the purpose. Now you must note that this kind of waveform is alternating. Okay, another thing is that this is alternating, these are pulsating, and that this is variable waveform. So you must answer these kind of questions. Okay, what is AC, what is what kind of waveform is DC, what is pulsating DC? That's the thing. Now you can also write that what are alternating currents, and alternating currents. You can now define what is AC was the question. So alternating currents are those which change polarity and are periodic in nature. And are periodic. That is, repeat. What did they do? Repeat after certain interval of time. Interval of time known as time period. Okay. This is the concept of alternating current. Now you understand. Now you can understand that what is AC. This was the, you can say, define what thing is actually AC. And important thing is that the waveform the electricity you are consuming in your homes is AC. What it is? AC. You must know this, okay? At homes you are using AC. In your homes, the power you are using, it is AC. We use AC there. Alternating current, there is no DC. So we will now understand why AC. Why we are using AC? Why direct current is not being used in commercial purposes and in households? We are using AC. Why? So there are some of the reasons. First one is, the discoms, the companies to which you are paying the electricity bills and all those electrical power companies. Okay, electrical power companies do transmission and distribution of electricity in AC. So that's why you need to study AC. That is why it is important. This is used in commercial electricity is AC only. You need to understand that and why they are using. So these are also known as discoms. In different states, we have different electrical power selling companies. Those as discoms, those are electrical power companies. Transmission companies are also they're different. Anyway, so this is done in AC. Why this is done in AC? There are also some reasons of why they are doing this in AC, which is also a pointer that why we are using AC, that different voltage levels can be easily obtained in AC by means of transformers. So these are some devices. The principle of working of these devices is electromagnetic mutual induction. Okay. So you need to understand that another point is there. So I will explain that because these three are interlinked. Second, third is that economical. AC power, AC electricity economical. Why? Because I square R losses. This is known as heat loss. Okay. Are minimized. Can be minimized. Better you write that. Okay. So can be minimized. Here is an option you can so that chance of minimalization of these losses there, because more the losses, more will be the cost to this electrical power companies, and thus it is not efficient. So that is why we use AC. So now let us understand what I am talking about. Second point, different voltage levels can be easily obtained in AC by means of transformer. This step is necessary because of third. See, I square R losses. For minimizing these losses, one way to minimize these losses is to change voltage levels when we transfer power from A place to B place. Say. Different steps are involved in transferring power. So first of all, the power will be generated at plants, then it will be transmitted over long distances, then it will be distributed to you. So this whole step, long distances of wires are used, and for that losses have to be minimized. This is the most important step so that losses can be minimized. So to minimize these losses, one of the important step is you need to change the voltage levels. So changing the voltage levels is not that easy in DC. It is very easy in AC by means of transformer, because these transformers are operable only when there is AC supply. They can't operate in DC. Okay, because the working principle is mutual induction, and induction is always possible in AC, where current is changing with respect to time. Current must change with respect to time so that transformer can be operated. So this is can be operable in AC condition, and that's why different voltages can be easily obtained when we use AC system as the electrical power standard. Okay. Now, for understanding that how these different voltages can minimize the losses, how these different voltage levels can minimize the losses, we can understand by this rough example. Okay, so that this can be understood well. Okay, if I tell you about power is equal to voltage into current, you know this, V into I. Okay, fine. As I'm talking of AC system, so I will be using values. You assume that those values are RMS, but we will be talking separately about RMS. Don't get confused into that. Just concentrate here, okay? Suppose this is, you must understand, this is a symbol for, this is source symbol, okay? AC voltage source symbol. This is symbolic representation, okay? You must understand that. AC voltage source. So this electricity is generated at plants. Plants, okay, it can be thermal, nuclear, wind, hydro, solar, whatever. The goal is to generate electricity. Some voltage is maintained at plant, say V, okay. Then suppose this is point A, you live at C. Here is your home, where all your devices are there, okay. At home, all your devices, different things, different equipments are connected. You need electricity here. And suppose this, but this distance is very long, okay, 1,000 kilometers, because plants is not located to the back of your home, okay. So these are generally very long distances, 1,000 kilometers. And from carrying power here to here, you have seen those, you might have seen those big towers, no? Those kind of towers, they carry wire like that. Wire like that are carrying those big towers. The transmission stage, that is the transmission of this electricity power, whatever. So these wires must have some resistance. So I am calling that resistance collectively of total 1,000 kilometer line resistance as R. Okay, this all is general understanding. Okay, so it can develop interest in the topic. Suppose you have connected this to your home. Okay, now I am going to tell you how these different voltage levels can minimize your losses, I square or losses. How? Suppose 6 watt of power is required here. Your home requires 6 watt of power. Your appliances connected require 6 watt of power. This is quite a small number, but just for understanding, let us assume that you only need 6 watt of power. Already your consumption of home in kilowatts, but for understanding, I am considering 6 watt of power is needed here. So if I maintain this voltage, if this is connected, okay, if I maintain this voltage at say 2 volts, okay, this is general understanding. This is not the exact diagram when we talk of a real electrical system, but for understanding, you can generally, for rough understanding, you can assume this, okay. If suppose this voltage is 2 volts, okay, then this voltage is 2 volts. If it is maintained as 2 volts, okay, then the current drawn, if the demand is 6 wattage of power, then the current drawn will be 3 amperes, okay, for 2 volts. Similarly, if this can be also the case, if I give, suppose say instead of 2, if I give 3 volts here, the current can be 2 ampere. Current drawn will be 2 ampere, not can be, the current drawn will be 2 ampere because for it needs 6 watt of power. Okay, whatever it is, let us talk about I square R losses. Okay. The thing here is we need to see losses in this line. Okay, this R. Here the loss is I square R, that means 3 square R, 9R. Here the current is 2 amperes, so 4R is the loss. In both of the cases, the wattages of the power here is 6 watt, okay. But the loss is dramatically increased here. Where the current is more. See this current is high. Although the load is consuming 6 watt of power in your home, but voltage is 2. When voltage was 2, current drawn was 3 by this circuit. Ultimately, these are series, so this also 3 ampere flowing here, so that is why 9R is the loss. But in this case, as current is less, if this is maintained at 3 volt, then this is 3 volt. Okay, ultimately, if this is 3 volt, this is at V equal to 3 volt, then 3 volt will be here. So that is why this 4R will be the loss in this. So which is desirable in terms of loss? This is desirable. This case is desirable because the I square losses are less here. Observe that V is high here. Voltage is high in the second case. So So in AC, so what? So if it was, this is our RMS value. If I'm talking about AC, if this were DC, you can't change these voltage levels. Then you will be in trouble. Whatever the voltage is generated here, suppose if it is generating 2 volts here, then 2 volts you can't help. You have to be for 2 volt here, and then the losses will be more in this line. But in AC, you have a provision of transformer. Okay, you have a provision of transformer. So what you will do, if by use of transformer, this is a symbol of transformer, okay, what will you do? You will step up. You will just increase the voltage. If say suppose it is generating at 2 volt, you will step up the voltage to 3 volt, so that according to 3 volt the current will be flowing here, it will be less. Again, a transformer will be used here. Okay, that transformer will step down. Step down means step down the voltage. The voltage, it will step down again back to 2 volts, or any of the different voltage, 2 volt or whatever distribution level is required. Further, you can distribute in different voltage levels. Okay, the thing is, by manipulating the voltage, the current here is indirectly manipulated, and ultimately the losses are minimized. Losses are minimized. Okay, so this is the case. This is just for understanding purpose. This is complete, so that you can understand that why different voltages are required in case of AC. These are desirable so that we can minimize losses, and several other things are there. Okay, so these points are important. Okay, so you can just note these 3 points. Point number 1, 2, and 3, that why AC is desirable. Okay, all said and done. So till now we have understood this, why AC, what AC. Fine. Now let us, this is all about the introduction. Now let us understand some extra points, some points which are of general knowledge as well. So in India, in household supply, okay, if you talk about household, which is your home, household supply, it is generally single phase. Okay, generally single phase. Single phase means one conductor only. Okay, one conductor and one return part. That's why you have socket like this. This is earth. We denote this as earth, the green colored wire. Okay, this is earth, denoted by like this. Earth is for safety purposes. Okay, this is for safety. This doesn't play a role in the power flow. Okay, okay, so one of the wire is phase and another of the wire is neutral. So this is for completing the circuit. The return part for this current will be here, and it will be making a closed loop with this neutral part with the generating power plant. Okay, whatever. So this is this supply of voltage. We write it as the supply standard in India is 240 volt, 50 hertz AC. Now this is important. You must remember that this is the standard in India. Different countries might follow different standard, but in India, this is the case, 50 hertz, 220 volt. Now I am writing this 220 volt here. Okay. The question is how I am writing this 220 volt. See, I am just trying to give you an introduction to RMS, that why RMS is important. RMS, root mean square value, or average voltages, like that terms are why they are important in AC circuit. So this is the waveform. This is the waveform which you are receiving in your household supply. It is a sinusoidal. What kind of waveform you are receiving in your home household supply? Sinusoidal waveform or sine wave. Suppose this is the peak value plus Vm. This is exactly the opposite negative value, that is minus Vm. Okay, you can see this. I will focus on this 220 volt. Okay, I am writing this 220 volt. For different value of time, we are having different value of V. So how can I write a specific value in terms of number? If it was DC, suppose this is DC, suppose this was DC 220 volt. Instead of AC, if it was DC, I can write V equal to 20 volt. This is another case. But here, what number I should write? So, to make analysis of AC circuits equivalent to DC, we introduced these terms, such as, what terms we introduced? We introduced terms such as root mean square values, average values, average voltages, average current, okay, average power is also different thing, instant power. Those terms are here. Why these are there, I am going to explain in this lecture as an introduction part. How root mean square value is derived, what actually root mean square value is, we will be seeing in the further coming lectures. But for generally I will tell you what is the significance of RMS. That is because we need a number here. How we will analyze this waveform, what values will you use for calculations, and what values will you use for deriving some conclusion from this. So that value is RMS value. RMS value is nothing but that value of voltage or current. RMS value is nothing but that voltage or value of current which will produce the similar heat equivalent to a DC circuit. Okay, so to make the power analysis similar in both the circuits, DC and AC, this RMS value is used. Okay, so there is a procedure to calculate RMS value of this sine wave, but as of now you need to understand that this value is RMS value. What value is? This is root mean square value, or we also call this as effective value. Okay, because this is equivalent, this value is the amount of voltage or current which will give the equivalent heat compared to that also the DC circuit. So that is why, that is the definition of RMS, different thing, but here it is RMS. Don't get confused, these are peaks, these are different. This is not the 220 volt value. 220 volt is different value which is calculated in a different manner, which is first we square the terms and then mean and root. That is a different thing, you will understand later in the next lectures, but this is important. So what is RMS value? So this value in India, whenever we say 220 volt, it is RMS value, and the frequency is 50 hertz. Frequency you can understand easily. This is one cycle. How one cycle? After this thing is repeating now. So this is one cycle, or the time elapsed for this one cycle is time period. Okay, time elapsed during the completion of one cycle is time period. Okay, so you can easily, you can say how frequently these cycles are occurring. This waveform consists of cycles, different cycles. How many cycles? How frequently these cycles are occurring, or how many cycles per second? Okay, how many cycles per second, which is frequency, and frequency is 1 upon time period. That you already must have known from those SHM. You can find the time period of this. If it is T equal to 1 by F and 50 hertz is the frequency, obviously time period will be in seconds. If you will calculate this, you will get 20 10 to the power minus 3 second, that is 20 millisecond. So you will be getting 20 millisecond. That means this wave on this time is 20 milliseconds. So whatever, you know, this is the frequency. So this is the standard. How many cycles per second? That is 50 cycles per second, 50 hertz, and this is the RMS value. This is the way, and AC. This is the way you represent a power supply. So in India, we are with this power supply standard, 220 volt, 50 hertz AC. Okay. Now, I was telling you, I was giving some example here. Okay, 3 volt and this. If it is AC, same thing here. How I am denoting this number? This RMS. Okay, every value is RMS. And then if anyone asks, sir, how are you using this constant values in AC? So these value, whether referred or whether mentioned or not, by understanding you must know that these are RMS values. Anyway, this was for just for understanding point of view, this example, you just need you must know what is AC, its definition. Those pointers were there that were important, that why AC is important, and those graphs. Okay, so this was about the introduction. So if I see the text, the same thing has been explained here. Okay, this is all the same thing I explained, and whenever we tune our radio to a favorite station, we are like, okay, this is also another thing. So ultimately, at the end of this alternating current, second last topic, probably we will be learning a condition known as resonance. Okay, and that is the working principle of radio. And the radio, thus, is resonance is possible only in AC circuits. So that's why radio is possible only because of AC systems. So that is why so many devices are there which are possible because of the AC concept only. DC is not suitable everywhere. Although batteries for storing electrical energy can be stored only in batteries, and that form is DC only. Okay, DC only in batteries. So when it comes to storage, AC can't be stored. AC can't be stored. You cannot store. We need to convert this into DC and store. Ultimately, batteries are for that only. So DC supply, charges can be stored, or charges can be, DC can only be stored. You need to understand this. AC can't be stored. That's why batteries are important. Everything has importance in their own respective fields. So we need to understand that these are important. AC system is important. The supply we are using in our homes is AC only. So this was it. In the next lectures, we will be starting the unit, that is AC voltage applied to a resistor. So with this, actually, the chapter will start. Till now, we discussed about the introduction portion, and we got introduced. So let's see how this resistor behaves, what current, how the current is occurring in this circuit, what is the power, and we will numerically derive what is RMS and average values in the next lectures. So thank you for watching. Any doubts you can mention in comment section. Let's continue in the next class.